With this, I want to move to session number 2, supplements, pathway to success and pitfall to avoid. We have a great moderator who knows the topic better than anybody else. He was a member of SC205, which is the other side of Eurocase Working Group 71. Mark Lillis from Triumph. Mark, over to you. Thank you.
Thank you, Christian, for that introduction, and Terry as well, the Eurocase and our TCA team. Thank you for setting this up today. It's really great. So I tried to get into yesterday's session, and it was actually sold out. So very excited to speak today to everybody. And so can we get the first slide put up that shows the documents that we're covering today? So yeah, as was introduced, we're going to cover the 3 supplements to the core document, the 178, 278. And those involve model-based development, OO, RT, we'll talk about related technologies, as well as formal methods. And what you'll see is some people are like, where's the tools supplement? The tools document is not officially a supplement to the core document. So we're just discussing the supplements to the core guidance material. Tools are more of a universal topic, and so not a part of the discussion today. So if I could ask for the poll to come up. Actually, let me introduce my team members before we pop the poll up. I have Burak. He's head of development and quality assurance at Volocopter. Jeanne Larsen, software engineering fellow at Collins Aerospace. Amanda Melles is the DAO chief, airworthiness and Transport Canada hardware software design approval appointee, working for Mannarino in Montreal, Canada. George Romanski is our chief scientist and technical advisor for computer aircraft software for the FAA. And Guillaume Soudain, software senior expert at EASA in Europe. So thank you all for joining me on this panel. Some of you I've known for nearly 40 years, and others less than a year. So this should be a good, well-rounded discussion from some diverse experts in the industry, both new technology, old technology. I know George has been in the commercial industry before joining the FAA, so he's got a great broad background as well. So at this point, can we pull up poll number 6 for the audience? And that would be on your Slido. And so that's a question of, have you used the formal method supplement? Have you used the object-oriented supplement? And have you used the model-based supplement? And you can select more than one, obviously. And if you've done none of them, then nothing to select. So as those poll responses come in, and let me make that a little bigger on my screen so I can see that. We start to see that, as expected, you know, a lot of folks have got model-based experience, as well as the formal methods being the lesser experience documents. And so we'll touch on all 3 of those documents as we talk today, pros and cons. We're going to treat this as kind of a get-together of nerds around the table, just talking about technology in a kind of after-dinner setting. So if my teammates could all unmute as necessary. What I want to do is, we did have one question that came to us before the session started. And that question was around the model-based supplement. And so that question came in, and I'll paraphrase. It talked about model traceability to traditional requirements is not a trivial issue and require a very detailed methodology in the modeling standard. A lack of guidance from that perspective could have led to the author of the comment stating that they had faced significant challenges tracing the model and that they could not understand the traceability logic, and they were finding it very difficult to complete this task. So Guillaume, do you have a perspective on that comment and maybe kind of expand on your thoughts given that comment?
Yeah, yes, sure, Mark, and good morning, good afternoon to all of you. Glad to be with you today. I think the question we hear here is a known problem of indeed traceability between a model and a set of requirements is not a trivial issue, which needs to be properly guided, I would say, in the process development. So in the modeling standards that are developed for for accompanying the process. And that's something where the difference in notations, tools, etc., can make a huge difference. So I'm sure that the person that was raising this question was sensible to this aspect. And yes, that's a non-issue on which there is a real need for understanding at which level of granularity you need to go down, what exactly you're trying to cover, in which format as well, in order to ease the reviews. So that's a pretty technical topic that we have also guided on in the DO 331 ED 218 model-based supplement.
Great. George, FAA perspective on the same topic?
So a lot of this depends on your approach and how you manage the system. You know, when you try to compare two models, it's very hard because if you move some blocks, they no longer compare. So many people use tools to convert a model to a canonical representation. Once you have a canonical representation, it's a lot easier to trace out to the next level down, the next representation. Other people use diagrams and they draw bubbles around certain boxes and label those. So there are various techniques to actually identify components or elements, trace those. It just really depends on what your standard is, what your company does.
Jeanne, I know that your team has used the model-based supplement. Have you run into similar issues or found workaround solutions?
Yeah, so Mark, I do think that we have initially worked through some of those challenges with figuring out how best to document the traceability. But one of the things I do believe that the standard has brought forward is the requirement to have modeling standards. And so working with our teams and making sure that our modeling standards are complete and address these things, including how we're going to trace and at what level we're going to document things, has helped tremendously.
Burak or Amanda, any thoughts there?
Yeah, maybe I would complement to what has been said here. My experience has a lot to do with the granularity, and I think it's partially is given the fact that some requirements are sometimes not detailed enough. So there is a lack of ability of the applicant or the company to establish the traceability between the requirement and the model. Or as well, I mean, the fact that the model is extremely complex and large in terms of logic that it implements, the traceability with the whole bunch of requirements becomes something very complicated to review and meet the objectives. Definitely, yes, the standards would help for sure to achieve, I would say, processes that are specific enough, because oftentimes we see very high level as well description to what needs to be done, but it doesn't convey completely how it should be done. And oftentimes problems are facing or encountered during audits, right? Sometimes a bit too late down the game. So yeah,
Burak?
that's my experience.
Well, I agree with all the experts here, especially what Jeanne has said. With 331, now we have a well-defined model standard. Before that one, that information is scattered all over the documentation. Some information were in requirements, some of them were in design standards or even in design itself. Now we have much more solid definitions how we are going to behave, how we are going to handle our models in that standard. So I think that's one of the opportunities which comes with the standard.
Yeah, you know,
Mark,
some of
if
the
I may,
conversation. Go ahead, Guillaume.
If I may just add something on this level of discussion, we are digging already into details indeed, because this question was bringing this level of detail. But it's really important, I think, to say for the audience that with all of these supplements, the 3 ones that you presented, we initially tried to solve an issue, I would say, with the special committee and the working group 71 SC205, which was to address techniques that were not that new, I would say, already used for years, but not guided in a way that was so easy to get to an harmonization point and a level playing field with the existing DO 178 and ED12 version, I would say. So we took the chance of that committee to create the 3 supplements in order to, I would say, compensate for something that was managed by certification authorities through a CRIS on the European side, certification review items, or IPs on the FAA side. And really the level of guidance at which we have come, I think it was a tremendous effort to find out all those common ground on model traceability in a model-based supplement, but on many other topics, in order to provide a minimal set of guidance. And I think that was a huge opportunity to simplify also the way certification projects were going on, because of course it's an administrative burden to manage CRIS, to manage IPs, but also it's a potential for not being completely harmonized with industry. So I think that's really important to set at the top of our discussion.
You know, there was a discussion also about in the model-based supplement allowing you to take a different perspective on how you treat systems and software, not as a hard boundary, and people talk about maybe a hybrid approach. You know, Amanda, is this something that experience with?
Yeah, for sure. And including, I mean, to complement what Guillaume just said, I mean, prior to the supplement was, of course, companies were already making use of models. And for sure, it's very powerful and something very, very useful. However, there's the draw the line or differentiation between, am I specifying systems using models, or am I specifying software using models, or oftentimes both. So I think the framework that has been presented in the supplement is very useful for that matter, because it illustrates different examples to where the models can fit into your design, and how you have to ensure that that's going to be properly implemented, properly verified. And yes, oftentimes we're going to see that the hybrid approach, where common processes, sometimes the system blend with the software processes, have been put in place by organizations to address the use of models into different levels, systems and software. It's very interesting.
George, do you have any perspective on how that's worked for the FAA during certification?
Yes, the system engineers very often have modeling notations, which they know and they understand, and they can describe how the aircraft behaves, how the components interact with the aircraft, and it's a very natural way of specifying what the intended behavior is. And that is if the system engineers can express that, then surely we should be, as software engineers, we should be able to take those specifications and use them when we develop the software. And it's that interaction that's powerful.
So for the audience members who may not be familiar with the subtleties of this supplement, we've correlated this concept of specification model to align with the high-level requirements of the core documents, and something called the design model that aligns with the low-level requirements. And I think an area where people struggle is that sometimes when folks are working in the systems world, they're really creating design models. And some people recognize that very well and some people don't. In other cases, they try to create specification models, but they're really creating design models. And in other cases, people are very successful at creating truly specification models. So Jeanne, can you maybe give us an example of where you've seen this work well and not work well?
Yeah, you know, just building on the conversation that someone said earlier, this technology has been around for a long time. I've been working with what we would call model-based design probably since I started in my career, but obviously not with the technology we use today. And largely design models, as you mentioned, right? Models from which you could generate code, whether it's by hand or automatically. But more recently, I think there's been an effort, especially in our company, to understand and utilize specification models that define constraints of the system at the high level, and whether they're in the systems world or they're actually across the system software boundary. That's been very valuable at validating the requirements above the model and finding inconsistencies or finding gaps. And then, you know, going back through that cycle to help refine and get a better system definition, really, before we continue with the detailed implementation. So early on in our use of that, of course, that we're all learning, but I think it's got a lot of potential.
Yeah, okay, so using something that you call a constraint model, which really isn't trying to create the detailed implementation requirements, but help people understand functional constraints and parameter limits.
Correct, and then we can use it later on to make sure that our implementation hasn't violated those expectations.
That's great. Anybody else have experience with specification models that have worked? George, have you had some experience in that area?
I would like to pick up on the constraint model notion. You know, you can express all sorts of behavior and you can express partial behavior. So for example, you can specify, you can use a transition diagram to specify what the states in the systems are. You can use a notation which expresses the initialization sequence, and there's all sorts of ways of using notations to describe certain parameters or constraints. And these should be able to feed into our modeling notation. They may not be classed as models. They only document certain constraints or architecture, but we should be able to use them and allow them to contribute to the specification of the actual system.
Yeah. Let me up there to the audience here. Where do you see people having the most difficulty with this? You know, you could pick one or two things that really stand out that you bump into that, you know, people making a set of text requirements that mirror the model requirements, and therefore you can't figure out which one is the driving requirement. You know, does anybody have examples of that sort of stuff?
Yes, Mark, if carrying on the discussion on specification model versus design model, I think this is a point of struggle indeed, and not saying that it cannot be successful, but really applicant has to be very careful with the definitions on that aspect. And we've seen a number of challenges in applicants, I would say, slicing a same modeling notation, the top layers from a hierarchical model, calling it a spec model, which doesn't work well in general. And also people really mistaking, I would say, a set of two design models at the same level of abstraction as the top one being a spec model. And that's the typical case, the typical flows. But I would say, to reassure the audience as well, this is the typical discussions we have when they present a process. And obviously, this is something we can pick up quite early in the process, discuss, and find out with them if there is real potential for it being a spec model or not, knowing that the supplement, and that's what I say always when I train on DO 331 ED 218, the supplement has been written with the design model in mind, which was the origin, I would say, of the CRI on the EASA side, and then ported to the supplement through the discussions with industry in the working group. And having put the spec model on top of it was more recognition that forcing people to have textual requirements above a design model would probably not be very future-proof. And that's where we started taking, I would say, UML or SysML as examples, saying there is a real potential there, so let's go for that. And that's really important to keep that in mind, because when reading the model-based supplement, it's easier to read it from a design model perspective than ramping up to spec model when really, I would say, necessary.
Great. So any last, go ahead, Amanda.
Yeah, just to complement to what Guillaume said is very interesting. And I would add, Guillaume, that having like a different level of abstraction in different model layers, it is a struggle. I mean, it's not as so easy to implement properly. But I would even attempt to say that some applicants struggle to do that even with textual requirements, because knowing exactly what you're specifying and the level of abstraction you're bringing at each layer, it's oftentimes a challenge, even when you use textual requirement. However, we know that textual has been used more spread for so many years, so I think it helps in that regard.
You're absolutely right, Amanda.
Mark, even going further in details, I would like to step back a little bit and start from the basics, because I think that's highly correlated how you are going to have your model related to our requirements and your source code. And I would like to underline another pitfall regarding choosing how you are going to use your models. As you know, we have a very famous table in our supplement, model usage examples, and that provides 5 examples. As the name indicates, actually, this is that just provides examples, so you don't have to follow one of them. You can even define your approach if it is more suitable to you. But let's say that you want to choose one of them. Most of the new players would have a tendency to select example 5 because it provides less documentation I mean, you just have some requirements at higher level. A design model covering almost all development activities, and just source code, in most of the cases, auto-generated source code. So it seems like it is the simplest approach, easiest approach at all. But guess what? My worst cars says otherwise. Because in my experience, when you try to satisfy the multiple needs of multiple parties, multiple disciplines, then you need to find a very good balance. And you need to have a very experienced team, both on system side and on software side. In the specific examples, for example, you write your requirements abstract enough to be accepted as system requirements, but on the other hand, they should be detailed enough to enable you to create some models that will be detailed enough to generate source codes or write source codes manually. So it's not a very easy balance when you just use example 5. So I would highly encourage people to choose the model usage scenario, not depending on number of artifacts, but rather experience of your team and your system's complexity.
Excellent. So I think at this point, I would like to jump to the object-oriented techniques and related.
Mark, if I may say just a word on what Burak said, it's really, really important what he said. Those examples were not tailored indeed to make it more or less complex to comply. It was really meant actually, and that's the way the model-based supplement is written, to have a consistent set of objectives, whatever the level and the organization you have, even considering the split system software. So it's really flattening this boundary, applying consistent set of objectives. That's an opportunity in itself, but it comes at a price of making the supplement quite complex to understand. And I think it's really important for the audience to know that the first time you read the supplement, you have to concentrate very hard on this MB1 introduction. I would say all the paragraphs there to really understand the way it's been constructed and the way it can be used. So it's a step. So it comes at a price, but I think in the end, what you said, Burak, is true. But we have a consistent set of objectives, whatever the approach, and that was the real driver, I would say, of this supplement.
I agree. Let me grab two Slido comments right now. First one is, what is the value and need to have the model traced to a higher level requirement? Should the higher level requirement be a textual requirement? I'll give a shot at answering that. The first part is, there is no mandatory requirement for it to trace to a text-based requirement. But if you have a specification model, let's say you only have a design model, which is, I would say, the predominant item, then yes, it would trace up to a textual-based requirement, even if that text-based requirement is in your customer specification. And that's kind of what the big circle around the system activity is in example 5. So why do we need to trace up to the higher level requirement? It's a low level requirement, and all low level requirements have to trace up to high level requirements or be defined as derived. And so in my mind, that's the rationale for that. Blocks can't exist for no reason. And the objective of, I'm segueing now to the next Slido question on model coverage. If you have extra blocks that can't be traced and have extra functions that can't be traced, those are the things that should be uncovered by model coverage analysis. So the question is, model coverage analysis is vague, uses lots of terms like may, consider. If not using a qualified MCA tool, what should I do? Anybody want to take that question, answer?
You don't have to use a tool to do the coverage analysis. You can do coverage analysis by review. It's easier for you if you have a tool, but the idea is that we need to identify extraneous behavior, because our extraneous behavior could be unsafe. So coverage analysis is just basically coverage analysis is a measure to make sure that we haven't introduced any new functionality.
Yeah,
Yes,
I would say, yeah, go ahead.
Sorry, Mark. I support the view of George that a tool is not a must, and that's why we have so many maze, I guess, in the guidance.
Yeah.
The very important thing with structural coverage analysis and let's say model coverage analysis, which is the new activity brought in the model-based supplement, is about really the criteria you use. Because to unveil this unintended behavior that George was talking about, you really need to have a very specific criteria that is oriented towards model functionality and specific to the design that and modeling notation that is used. So it's really it's a very important aspect, but it's an activity. That's why the may as well. It's not a forced objective in itself, but it's a really added value activity if conducted properly.
Yes, and so what I want to follow on with that, when we created this, we did not want to be prescriptive about this is the perfect method to show completeness of verification and identification of unintended functionality, because we didn't know what your process may be. So we are only stating in MCA that we want you to define something that is comprehensive, that will find missing and extra requirements in your models, things that your verification isn't finding, either because the verification is incomplete or the verification is actually identifying something that doesn't belong. Jeanne, Larsen, and I, many years ago, back in the early days when we only had pens to do model-based development, we use something called yellow pen testing, which you just highlighted, and when you had something that wasn't highlighted because you couldn't find a verification step for it, that was potential unintended functionality. So
the funny thing, Mark, is that
yeah.
the funny thing, Mark, is that it's still used sometimes.
Yeah, and it's
works.
still very effective.
It
Yellow
works.
pen testing. Okay, so with that, I think I've covered the kind of top two Slido comments. I'd like to jump over to object-oriented supplement and maybe start with George. George, what's your opinion on how this supplement has been used in the industry?
For the most part, it's used quite successfully. There are those applicants that overcomplicate things. And it's frustrating when you see a language and the language has all sorts of new fancy features, people try to exploit the language features in their application, and even when it's not necessary. And then we start having all sorts of complications, and they said, oh, how do we verify this? We said, don't use it. So there are features in object-oriented languages where you have dynamic memory allocation, where you can have constructors and destructors, where dynamic memory is really complicated when it goes in and out of scope. And then people struggle with memory management or verification of memory management. And my view is initialize everything at the front, and then don't worry about initializing stuff dynamically as it goes in and out of scope. So simplify it, don't use all the features of the language because it just complicates the application.
Very good. Jeanne, you've done some object-oriented work in your day.
Actually, not really. What I will say about the object-oriented supplement is that maybe a little bit to George's point, right? You have different people who have different roles. And so the folks who are doing the low-level implementation, they adopt the language and they dive in and they use all the features. They may not be the people communicating with the folks who are writing your plans, right, or your standards. And so sometimes I think you find out late that perhaps you use some of these object-oriented or related techniques, and you have to go back and understand the objectives that you need to meet in the supplement. So I've actually seen that happen occasionally. And that's something that you just want to make sure there's a good awareness of your team that there's objectives related to those things, I think.
Guillaume, how about you? What have you seen?
Mark, did you address me? Sorry, it was cutting out for a second.
I did address you. What
great.
Guillaume?
What I've seen is, I fully also here relay the message from George. It's the important thing is keep it simple. I mean, the power of object-oriented techniques is to create really robust and modular software architectures, and that can be of a tremendous help. And that's where I think the object-oriented technique supplement is really is a specialist supplement. So in general, we don't have so many difficulties with applicants using it because they really know what they have to do and what they want to do with it. And the supplement itself is a very technical supplement, so it comes also at the cost of understanding it, but it drives very easily a common understanding in the vulnerability analysis on the specificities of OO. So I really think it's not the one where we have the most troubles, I would say, in the discussions.
Yeah.
Very good. So we all know that.
If I could add, Mark, if I could add.
Go ahead, George.
The model-based supplement or object-oriented programming lends itself very well to people mapping it onto real applications. I've had examples or I've programmed examples where I had a pump or different types of pumps or different types of tanks. So I had objects, which was here's a pump class, here's a tank class. I want to connect them. I can create an object with a pump. I can create an object with a pump. And there's a very natural mapping between my software and the application. And because the mapping is so natural, it's very much easier to develop, to debug, to get right. So if used well, it's a very powerful technique.
Do you see anybody here see a blending of both the object-oriented and the model-based supplement being used together? Do you see that in practice?
Not much.
No, not much. No.
Okay. Oh. And for the regulators, we all know that the RTC and UK documents don't have any power until advisory circular comes out and says these are now the rules. And so some clarification notes related to this OO and RT supplement. Is there any background on that we can share why it's kind of worded a little different than the other supplements? You know,
I mean,
the
Yes.
story nature of the
Amanda, please.
related technologies, for example.
yeah, just a little bit. So I prior to the supplement, OO was used a lot as well. Prior to the supplement, I think the benefits as a supplement brought is the fact that it's very clear into the vulnerabilities that needs to be addressed with the use of the technology. As opposed to before, to be always like more an ad hoc or up to the company to come up with the means to analyze the potential vulnerabilities of the use of that language. I think the OO supplements support for that. However, honestly, what I've seen is a lot of applicants running away from OO still, not for specific reasons. Of course, there are many vulnerabilities, so you need to address. However, there are challenges, especially for structural coverage, I believe, when it comes to assessing the code. That's one aspect. And the other aspect is that the powerful portion of OO is the fact that it's high level of reusability. So if you're developing a product in which you're going to apply to multiple customers, or you have a product line that makes a lot of sense, in some other cases might not be as justifiable to use. However, new applicants, they use quite a lot. I mean, there's air mobility, for sure. There's no limits, and a lot of people are using OO. And again, free for all oftentimes, so that needs to be for sure looked at.
So
Yes,
would you
and
say
Mark,
an underlying message is simplicity, both in OO as well as in model-based? You know, so remember that, folks. Burak.
Yeah, I was going to say similar things. Amanda, you said that structured coverage analysis might be an issue at OO, but I think it comes to the same point. For example, yes, if you use inheritance intensively, if you are lacking type consistency, then yes, you will going to have lots of structured coverage, especially when you are on DAL A or DAL B. So I think the main takeaways from object-oriented is keep it simple as possible during the implementation.
Jeanne, I think you've had some success, and I'll call it with OO-like programming style. Okay, you want to talk about it?
Yeah, I mean, I think, you know, what I've done and what you're referring to is very similar to what George talked about, right? So we haven't really used object-oriented languages, and we haven't used these related technologies or features. But at the architecture level, at the design level, you know, we've created packages that are aligned with hardware components like pumps, like valves, right? And then the understandability from the requirements to the implementation is easier. And I think Amanda mentioned, and then for product lines or reuse or derivatives, there's a lot of value there as well.
Great, thank you. We have one Slido comment that was making it up the charts about does FAA EASA allow any other languages than C++, Ada in DAL C or higher? How about DAL D? So I want to know, where did the notion come from that there's any rules about a language? So I'm throwing it out there.
That's an interesting.
Get the idea there's a rule.
That's an interesting question. No rules. It's as usual. The set of plans, an applicant really proposes a method, a language, etc. And of course, we are more accompanying in order to see where are the safety risks and what could go wrong. But there is really no barrier, no limit in the usage of object-oriented languages to a given level, I would say first, but also to a specific type of language, whether C++ or ADA. There is no limitation here.
Except that you have to control your environment, right? So other than that, you can homegrown your compiler, but at the end of the day, you need to. That's it. Yeah, I agree.
No, I struggle with certain. I mean, you said there's no limits. Well, I struggle with functional languages. A functional language is one where you have no assignments. You can make the code extremely small, but then everything is dynamic and it's not deterministic. So I've seen people write a compiler, which normally would have been 500,000 lines of code, and they write it in a functional language, and it's only 50,000 lines of code.
Absolutely.
The trouble is, we don't care about performance times there. We don't care how long a compiler takes. And that's a problem I have with functional languages. So there are limits. We want it deterministic.
So
absolutely.
Yep.
And that's exactly what the OO supplement helps us doing. That's why I was saying no limit, and let's say until we can still comply with the guidance that is available.
So to paraphrase one of the questions on Slido, it's I'm an applicant. I didn't use any OO techniques. Can I just ignore this supplement, or do I have to still call it out because of the RT items?
This is what we exactly tried to clarify in the AMC AC 2115D that you mentioned before, Mark, which is calling the suite of documents, and just to really say that there could be some guidance in this OO supplement that could be interesting for the related technique part, for instance, but there is no applicability that is driven by this side.
So from a regulatory point of view, would you like me to call it out and say, I looked, it doesn't matter to me, or to just ignore it?
Ignore it if there is nothing that drives you in the applicability area. That's really the message. We don't want to over complexify. The DO 178 core document is complex enough so that we don't draw really things for fun. It's really with no jokes. Ignore it until there is a real reason for entering it. But
and I'm going to try to use the word complexify 2 times a day. My normal speaking. Good new word. Anything else people want to talk about on the OO? We've talked about some of the highlights, structural coverage, vulnerabilities. Anything before we spend our last few minutes on formal methods? Okay, so let me start right there and start with George and Guillaume and say, have you done a full method certification?
I've never seen a full up use of formal methods. We have tried in the past, I've tried in the past. The thing that I found was that the formal methods was great at specifying because it stopped all the arguments. We could formally specify what the behavior was supposed to be, and people would no longer argue what it really meant. However, using the formal method supplement to actually take it further is really tough, because while we want it to be deterministic, at the other end, we have compilers that are adding in all sorts of optimizations. We have the target computers, which are adding all sorts of additional behaviors behind our backs. And it's really hard to take formal methods all the way through. However, if you want to exploit certain properties, it is really good. If you can use a formal method to specify that there's no overflow, for example, then use it. If you can use a formal method technique to specify some testing characteristics, test sets, then use it. You don't have to use the full amount.
Yes, I relay your message, George, as well. We've conducted some certification on the other side with it. One of the challenge being that if you start using it for, let's say, pieces of your development, you enter in some troubles with the structural coverage demonstration at the end. How can you mix testing and formal proof is quite a complex issue that was not solved at the time of creating the supplement. But when used really all over the place for certain module, it doesn't have to be for the full software. It's extremely powerful. However, and that's the point I would say, there are still a lot of limitations from a computational perspective that you cannot overcome today. So it's not widely used, and that's what we saw on the poll. And it's not widely used at higher level of abstraction. It's used for unit proof at code level quite successfully today. But when it comes, for example, to model checking, we've never made a certification project that uses model checking extensively. It's more used really for sample checks.
Very good.
So my point was to
George,
use it for. My point was to use it for specific properties.
Mm-hmm.
So rather than write tests for overflow checking, why not use a formal method to specify that your algorithm will not overflow, for example?
Yes. And this is used, by the way, George, in some tools using formal methods in order to prove this type of properties. Fully agreed, yes.
Jeanne, did you have some experience with the tool example that Guillaume just mentioned?
I think that's an area that we're starting to look at where I think there's some tools that actually use formal methods as part of the tool qual or the method that they use for verification. So we are starting to look at that as well, but not in the embedded application space, just for tools.
Yes, certainly tools that do static code analysis. Static code analysis is essentially a formal methods activity. To George, I can't, or I might get an overflow here because, I'm dividing by potentially 0 here, or this calculation is an array index and it has the ability to calculate a negative number. That would be bad. So those sorts of formal checks on source code are pretty powerful, but they're not the code themselves. Agree on that. So I want to flip over to Slido here, and we're getting a few more comments on model coverage analysis. MC, very tricky part. Their models implement more details than the text requirements, or either the textual requirements or copy paste of the models. I think it's this one-to-oneness. I always say two things that are similar are different. You can't have a model requirement and an exact equivalent of a text-based requirement unless you have a very formal method style text-based requirement, where I see a lot of commonality between the formality and the model-based. They're both very formal. So how do we resolve this issue of coverage and the gap between the behavior of the model always either being a little narrower or a little wider than you really want? Any thoughts on that?
I don't know if I just may add to what you said, Mark. In terms of it's very common to see the fact that some applicants had started with the model and now they have to comply with the supplement. So what they do is they reverse engineer they reverse engineer their models and they come with requirements. So that's the first problem that I've seen, is the fact that the requirements are the pure English translation of the model. So it's very hard for you to achieve a meaningful coverage analysis if that is the case, because the way it's supposed to be, you're supposed to have functional requirements that will fully exercise your design when you verify. And that verification means testing, analysis, review, whatever you have to do to achieve the coverage. I think that is one of the main problems with people when they try to achieve model coverage analysis, because the requirements are not functional requirements. That's my experience.
Great. Well, that is going to be our last word for the day. So thank you everybody for participating, and I think I'm handing this off to
Thank
the
you.
moderator again.